Welcome to my video lecture based on reciprocity theorem. This topic is included in the paper of electric circuit theory, paper name paper code PCE 301. The total topic and total syllabus is based on knockout curriculum. Myself, Kunun Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra Degree Engineering College. In my previous lecture, we have analyzed different network theorems, different laws of network analysis like Ohm's law, Kirchhoff's voltage law, Current's law, and different theorems to solve the network analysis problems like superposition theorems, Thevenin's theorem, Norton's theorem, Millman's theorems also I have discussed. Basically, those theorems are helpful for solving different network problems which are basically complex in nature, but these theorems can be makes the total network in a simple way, and it will be easier to solve the problem using these theorems. So, based on this concept, different theorems have been developed, and among those, reciprocity theorem is another part of this theorem. So, this is the last topic included in the network analysis module. So, let us start with reciprocity theorem in this section. So, what is reciprocity theorem and why it is used? This theorem is applicable only for single sources. This theorem is applicable only for single sources, and it is therefore not a theorem employed in the analysis of multi-source network described so far. In our previous cases, we have applied different theorems, and those theorems are based on different multiple sources are active and how those can be solved in an easier way that we have seen in our previous lecture. But this theorem is not employed for multi-source network. And the statement of this theorem is as follows: the current I in any branch of a network due to a single voltage source E anywhere else in the network will equal the current through the branch in which the source was originally located if the source is placed in the branch. In other words, the location of the voltage source and resulting current may be interchanged without a change in the current. So here, as per this reciprocity theorem, it states that if a single source is present in the network and we want to measure a current through a particular branch, then whatever amount of current is flowing through that branch, so the fact is here, when we will want to measure the current through a particular branch for that given source, suppose we are getting the amount of current is 5 ampere to that branch. Now, if we are replacing that voltage source in the same branch where the currents we have want to calculate, and then just if we calculate the current through the voltage source which was present previously, we will get the same amount of current, that is 5 ampere current will be flow in the voltage source branch. That means if we just interchange the position of the voltage source with the current measuring branch, then the same amount of current will flow through the voltage source branch and as per previous current branch. Now this thing will be much more easier to understand when we will show it through some examples. Then this is our network, and here E is the voltage source present here, and we want to measure the current through this CD branch. Okay. Now suppose the current through the CD branch is I. Now, if we reciprocate that voltage source in that CD branch, then like this way, we have just interchanged the position of voltage source here. Then the same amount of current will flowing through the voltage source branch AB. So see what's happened? I have just replaced the AB branch into CD branch, and the same current is now flowing in the reciprocate way. That means AB branch voltage is now CD and CD branch current is now in AB. They just interchange their positions. Okay. So that thing is possible in case of reciprocity theorems. We can see that these things are really happens when that voltage source is just replacing that particular branch. So let us verify the reciprocity theorem. Whatever we have told now, that is really truth or not, that we will see through this example. So here there are 2 ohm, 3 ohm, 4 ohm, 5 ohm branches are there, and now we have to verify the reciprocity theorem. And this is basically the actual branch. That means here a voltmeter is connected, and here we will put a current source. Okay. Now we have to see that when we will just interchange this position of current source and voltmeter, then the same amount of current we are getting on. So this is the circuit. Using the current source and the voltmeter, we have to prove this. Okay. So we are applying KCL in node 1 here. KCL means summation of current switching at a node equals to 0. So in node 1, the current entering, that is 3E1 minus E2 minus 2I1. Okay. Here E1 and E2 are the node voltages, and V1 is the voltmeter reading. So node voltage definitely, that is E1, so it is 6E1, 3E1 minus, this is 3E1 minus of E2, this one E2, and 2I1. So summation of current switching at a node equals to 0. Here this is only this direction and these are in this direction. That means all the currents except 3E1, all the currents are in opposite direction. Then similar we will apply it into node 2. We are getting that 6 minus 6E1 plus 13E2 minus 3V1, that is we are getting in node 2. This one. The reading of the voltmeter is 0. So from calculation of these two, we are getting that I1 by V1 equals to 1 by 5. Now we will just replace the position of voltmeter and current source. In the same way, we will calculate node 1, node 2 and node 3, and we are getting that the same thing, that is current divided by voltage, that is equals to 21 by 5. That means from the equations A and B, reciprocity theorem is true. Now let us consider another example. Here we have a voltage source which is 200 angle 45 degree. Then a 20 volt source, J10 ohm reactance, 20 ohm minus J10 capacitive reactance and 10 ohm resistance is present. Now we have to verify the reciprocity theorem. So for verifying this reciprocity theorem, we have taken help of Kirchhoff's voltage law KVL. Okay. So we have formed three loops. In first loop we have taken current I1. In second loop we have taken current I2. In third loop we have taken current I3. So the equation of first loop will be 20 I1 plus J10 ohm bracket I1 minus I2. That means ultimately 20 plus J10 I1 minus J10 I2. That is equals to 200 angle 45 degree. Next we have applied KVL in loop 2. We are getting that 20 I2 plus J10 I2 minus I1 plus minus J10 I3 minus I2, and combining this we are getting minus J10 I1 plus 20 I2 plus J10 I3. In third part we are getting that J10 I2 plus 10 minus J10 I3 equals to 0. These three equations we are getting. Now solving using Cramer's rule, we are getting the value of I3 equals to this one. Okay. So 2.169 angle 57.53. Now we have just replaced the position of voltage source with this. These are branch, this one. We want to just calculate the current of this branch. So we have just replaced the position of voltage source here to here. Okay. Like this, the diagram we can solve this. Now we will again apply KVL and we will form the equation in a similar way. This is the first equation where no force is present in loop 1. Then equation 2 for loop 2 and equation 3 for loop 3. Again using Cramer's rule, we have solved the current for loop 1 because we have replaced the path now, and we are getting that same amount of current is going through in the just replacing branch, the same current is flowing. In the case of voltage source branch, same 2.169 angle 57.53 degree ampere is flowing. So in the both cases we are getting the same amount of current, so we can prove that reciprocity theorem is verified. This is a very interesting topic that you can just take in one network and just replace the source with a particular branch, and then you can calculate the current in the source branch. You will get the same amount of current there. So that is basically reciprocity theorem. I think all of you have understood this one, and you can get different types of problem related to this topic of reciprocity theorem in the book of circuit theory by Reciprocity. And I will prefer that you just practice those problems, and you can also try by your own choice different problems, but you have to remember that this theorem is only applicable where only single source is present. This theorem has a limitation, that is, it is not applicable for multiple sources. So remember this in mind and you just go through this problem. Okay. thank you. Thank you all for listening my lecture, and in my next lectures I will start with a new module based on knockout syllabus curriculum, and we will start with new chapter of circuit theory. So thank you all. Not much for today.